Okay, so here's the deal. When I threw the bowling ball, I gave it something. What did I give it? Oh, I didn't give it a force, did I? I gave it, the word for what you're looking for is momentum. When you throw the bowling ball, it started out, it didn't have any momentum, but when you threw it, it now has momentum. Got it? That's the word you're looking for. Now, in order to get rid of the bowling ball's momentum, what do you have to do to the bowling ball? Push it. Which way did you have to push it to get rid of its momentum? You got to push it backwards from the way it's going. So here's the words and the way the words work. Momentum is something that a ball can have. Like right now, how much momentum does that bowling ball have? 0, right? Now, if I wanted to give that ball some momentum, what would I have to do to it? Push it, which is also known as putting a force on it. Does that make sense? So, an object has momentum. It doesn't have a force. That actually doesn't make any sense to say it that way. Force isn't something that you can carry with you or you contain. You don't contain a force. I don't even know what that would mean. Force is a push or a pull, right? You can force something to do something, right? But you don't have a force. Does that make sense? But you do have a momentum. All right? And the big idea here is if you didn't push that bowling ball at all, it was rolling along, what's it going to keep on doing? Keep on going. How long? Forever. Did you know this? If you had a bowling ball that was moving, it has momentum, right? It's got its momentum, and you don't do anything to the bowling ball, there are no forces on it at all, what's the ball going to do? Keep moving forever. Now, have you seen this happen in real life, a bowling ball that keeps on going forever? Of course not. You know, a lot of times you notice that a bowling ball might slow down. Why does it slow down? What is pushing on it? Friction. That's a force. Friction is a force on an object that causes the ball to slow down. Does that make sense? So there's 2 words you need to know so far. First one is momentum. All right? Isaac Newton called momentum the quantity of motion of an object. How much motion does that thing have right now, that bowling ball? None. 0. But if it was moving, then it would have some momentum. Good? All right. The next term you need to know is force. A force is a push or a pull. That bowling ball doesn't have a force. Even if it was moving, it wouldn't have a force because that doesn't actually make any sense. All right. Good so far? All right. Next one. Raise your hand if you took chemistry last year. Keep your hand up if your chemistry teacher told you that mass and weight are different things. Wait. Yeah? Keep your hand up if you completely ignored what they told you because it just didn't matter. It's true. Who cares? In chemistry class, it's like, mass and weight are different. You got to know mass, and then you got to know that weight is different. Why? It doesn't matter for chemistry. It doesn't matter for chemistry, but it does matter in physics class. In this class, mass and weight are different things. Does anyone know the difference? Yeah, okay.
Weight is the force of gravity being pushed down on you, and mass is just like how much you're saying there is.
I like that answer. Just for that, come on up. We're going to do a demonstration, all right? Ready to play catch? All right, okay, so I have two balls that they are the same size. One of them's a bowling ball. This little one is a little air-filled neoprene rubber ball. All right, you ready? 1, 2, 3. Okay. Which one weighs more? The bowling ball. Okay, good. Which one has more mass? Oh, not at all. The bowling ball, of course, right? Yeah, the bowling ball and it has more. It weighs more and it has more mass. Okay, so which one do you want to play catch with? The little light rubber ball. Why?
It's not as heavy.
It's not as heavy. Okay, fine. Let's play catch with that one. All right, ready? Here, throw me the ball. Ooh, this is fun. Oh, this is a good game. All right, do you want to play with the bowling ball?
Figure it
Okay, he doesn't want to play with. Why don't you want to play with the bowling ball?
I want to drop on my foot.
Ah, he's afraid that it's heavy. Well, I tell you what. Let's play this game of catch in a place where we don't have to worry about weight at all. Where do we need to go? Space. Let's go to the space station. Are you ready? Ready to play? Okay, so we are magically teleporting ourselves to the space station right now. Okay, now we're there. All right, we're going to play this game again. And we're going to play it in a weightless environment where there is no weight. We don't have to worry about weight, right? Because if we let go of something, is it going to fall and hit our toe? No. Okay, so here we go. Ready? Okay, so we're on the space station now. I'm going to throw you the ball. And you caught the ball. Good. Can you send it back? No. And it goes like that. Right, no big deal, right? Shall we play the same game with the bowling ball? All right, here's the bowling ball. Ready? Catch. Do you really want to do this? What would this be like if I threw the bowling ball at him while I was aboard the space station? What would it be like? Would it really be the same as that little orange ball? No. It would be very dangerous. Why? Well, fine, I throw it to him, it comes at him, and then he tries to catch it. What happens to him? It's like, doof, and then he's like, and like slams his head against the wall. You would not want to play this game with a bowling ball in space. Why not?
Friction.
Friction? What? No, there's friction.
No, wait, there's no gravity.
Wait, gravity. Wait, the gravity was the thing you were complaining about. You were saying it was heavy. That's why you didn't want to play with it on Earth. But there is no weight in space. Well, actually, that's a bit of a lie, but I'm going to go with it for now. You don't have to worry about weight in space. So why is this so bad? It's such a bad idea to play the catch on the space station with a bowling ball. What's going to happen to him when he tries to catch the ball? Can you mime it? Here, boom, and then you catch, and then you catch it, and what happens?
I go backwards.
It like knocks him backward, right? Why does it knock him backward? The ball doesn't weigh anything. It still has mass. Do you understand the difference? There's a property that you learned way back in like 8th grade or something. It starts with I, a word. You got it? Inertia, right. That bowling ball has a ton of inertia. Even though it doesn't have any weight, it's got inertia, and when it hits him, it's just gonna blast him, right? Things have inertia in space even though they don't have weight. Things have mass even though they don't have weight. Got it? They are not the same. But in chemistry class, you would never know that, because where did you never do chemistry experiments? In space. Got it?
That should be
It should be a field trip. So here's your assignment. I want you all to go into space and conduct chemistry experiments. Yes, make sure you do that and report back to me when you're done. I'll give you extra credit. All right. So, nice work. Thank you. Thanks for playing catch with me in space. All right. So, mass and weight are not the same thing. Here's the difference. Mass, that's the amount of inertia an object has. By the way, mass we give the letter M. Weight. Weight is how heavy it is. It's also known as the force due to gravity, because if you think about it, that ball is pushing down your hand, so it's a force, right? The ball weighs something. It's called the force due to gravity. It's got an F, but what's that little G mean? Force due to, little g means gravity. All right, so let's use some of these in a sentence, shall we? Let's start with force. Example, she pushed the box with a force of 100 newtons. Is that a lot of force? Kind of, not really. Not a whole lot. Oh, by the way, what do we measure? All right. Lifted weights before? Ever? Like occasionally? Right? What do we measure force in English units? Pounds, right. Did you guys know that? I lifted that, like the 45-pound bar, right? That's force, right? But in this class, of course, we're metric, right? We're SI units. What's the units of force? Newtons. Got it? Wait, but on the side of the little plate doesn't say kilograms? What's that? Pounds is in... Pounds is force, which is newtons. Mass is kilograms. But here on Earth, we don't care. They're kind of interchangeable. But you go up in space and try to throw a 22-kilogram plate at somebody, guess what's going to happen? They're going to have a bad day when that thing hits them. All right, so anyway, mass. Example, the box had a mass of 50 kilograms. It really hurt when it hit me. Got it? So that's mass. Weight. The box was really heavy. It weighed 500 newtons. Got it? So you should be able to use all of these in a sentence. All right, so that's it for now. I just wanted to say that we are going to go to a simulation, and this simulation's on SimBucket. It's called Rocket Sledder. So open up your Schoology.